Okay, here's the next one I wanted to do. It's on the same page in the e-text, which is, I think, 108. Anyway, this is, boy, I wish I were there right now. I wish I were in the land of cotton. No, I wish I were um, kayaking. Being outdoors would be nice. So I got to get out there. You too. Anyway, this is a kayak race, and Tony and Randy are racing their kayaks. As you can see, that doesn't look like Constitution Lake. Looks like they're on a river, but let's get real. They start the race at the same time, travel in the same direction. Tony's rate is 1.5 times faster than Randy's rate. And after 45 minutes, the two kayakers are 3 miles apart. Okay, so what's the question? Is there a question to this? Oh, I didn't copy that, I bet. Let's see. What is Randy's rate? What is Tony's rate? That's what it is. So what is Randy's rate and what is Tony's rate? Being, you know, new to math or rejecting of math, you look at a problem like this and go, how the heck am I supposed to know? Well, when I see them moving and they're talking about rates and stuff, again, I go rate times time equals distance. I build a table. Anyone can do this. You know, sometimes people don't do this. They go, I just don't want to do this. And they reject it. So anyway, but we have, there's Tony, and then there's Randy. Okay, so that's how you start it, and then you gain some more confidence. You read the problem, you go, well, let's see, they start at the same time, so the time is the same. For each guy. Okay. All right, I got that little bit of information. And they travel in the same direction. So this time they're not separate places going together, but instead they start at the same spot and you mark set go like a race, and slowly someone gets, I think it's Tony's going faster. Okay, he's going to win. Okay. Tony's rate is 1.5 times faster. They didn't tell us miles per hour or anything like that. They just said 1.5 times faster rate. What that means is if I'm going 10 miles per hour and you're Tony, then you're going 1.5 that. So you're really going 15 miles per hour. You're going 1.5 times 10 is 15, a way of doing it mathematically. Do you understand? I'm going 10, 1.5 times faster is 15, 10 and 15, going faster. So we don't know what the numbers are, but we can convert that into algebra by simply going, okay, let me read it one more time. Tony's rate is 1.5 times faster than Randy. So Tony's faster. So Randy, you just simply go, his rate is X. Let's call it X. I don't know. Call it R if you want to. You can call it capital R for Randy. In fact, that might be, let me show you that. Why not? This is more colorful. That's Randy's rate. I called it R. And Tony's going Randy's rate, but faster. Here you go. 1.5 times Randy's rate. That'll do it. So try it with numbers for a second. Just go, well, if Randy is going 12 miles per hour, how fast is, use a calculator. Oh, it's 18 miles per hour, that kind of thing. Now they're going at the same time. And what they said, there's a timer. They go, boom, 45 minutes. After 45 minutes, that's a time. So here's your first idea, 45 and 45, but there's a problem. Okay, how do you want to answer the rate? Do you want it, are you looking for miles per hour, or do you want miles per minute? Actually, that's up to the guy or gal that's doing the problem. It really is. My guess, if you look in the back of the book, you can see, or you can look at MyMathLab and, oh no, you got to convert and all that stuff. No one told you to do that. No one did. But you know what we're used to is miles per hour. So if you don't mind, I'm going to switch to miles per hour and not put in 45 minutes. I'm going to say 45 minutes is the same thing as 3/4 of an hour, right? And know what you're probably going to do is 0.75 hour if you want to. Okay, that's what I'm going to put in. Okay, you see the decimal 1.5 in the problem? I'm going to stick to decimals. First, I'll erase the 45. Why am I doing that again? Because I want to have the dimensions read miles per hour. So I'm going to convert the minutes to hours. And you should too. So we do, and we go, okay, it is 0.75 hours, 0.75 hour. But now, folks, we're free to multiply across. Anytime you want to pause and ask, what was that? Did you have a question? Okay. Yeah, we converted to hours, and we're filling the table so that we can now look at the legend. Rate times time equals distance. So we have a rate is 1.5 r times 0.75. And the next one, how about I write it as 0.75 times r? Those are the two distances. The distance, that's Tony's distance. In fact, you can write it down. You can go, in fact, I'm going to use a calculator. I'm going to go, are you ready? 1.5 times 0.75 is 1.125. So I'll write down Tony's distance is 1.125, did I do that right? R. So it is interesting. That's all I can say. And then Randy's distance is, and in that case, it's 0.75 R. Okay, look at the two numbers. Which one is bigger? Right? Which one? Of course, 1.125 is bigger than 0.75 because it is 1.5 times as big. Okay, it's 1.5 times. That's Tony's distance. He's going 1.5 times farther than Randy. All right, but we're not done. Remember that thing on the last one? You put the two distances, they add up. What happens in this case where one is edging slowly farther and farther apart? In that case, if this is Tony, and if this is Randy, he's slower. So this is Tony's distance is 1.125 R. Randy's is 0.75 R. And they said something about in the problem way up here, after 45 minutes, the kayakers are 3 miles apart. 3 miles apart. 3 miles apart. Where does that go in this picture of Randy and Tony racing? Yeah, I mean, it's this piece right here. Tony is 3 miles apart. This is Tony's distance is this miles. Randy's is this many miles. And then the difference between the two is 3. With this picture, I think maybe you guys can set this thing up. You can compare the two. From here to here, that's the same distance. So 1.125 R is the same as 0.75 R plus 3. That's right. Let's write that down. 1.125 R is equal to 0.75 R plus 3. If you're patient and comfortable, you'll get pretty good at this. Okay, so that's a setup. That's what you could do. No one told you what their speeds were, so all we have to do now is solve it, of course. But I wanted to talk to that. That takes some patience and drawing pictures and understanding, and it's a will, a desire. I'm gonna master these problems. I'm gonna be a rate times time equals distance guru. Anyway, to solve this, what we'll do is we'll go minus 0.75 R, and what we're doing is we're combining the two together on the other side. So if you don't mind, I'll go 1.125, excuse me, minus 0.75 is 0.375. So we have 0.375 R is equal to 3. So divide by 0.375, 0.375, and we're getting R is equal to that division. So 3 divided by 0.375 is 8. Did you know that 0.375 is really 3/8? Invert and multiply, you got 8/3, you get an 8. That's right. So R is equal to 8. For that last point, you go back to the question and they go, what is Randy's rate? What is Tony's rate? You know, I don't even have to go to the table because you know why? I remember what R stands for. It's Randy's rate. Randy's going 8 miles per hour. And Tony's rate is equal to 1.5 Randy's rate. So you go 1.5 times 8, and what that's going to get you is 12 miles per hour. And so what you want, this is Randy, should have written that down, and this is Tony, and this is you being done and doing a high five to your neighbor. Way to go. Yeah, got it. It's work. It's work. Don't feel alone because, you know, try to work with people, you know, get in a group and just try to train each other up. Online is, you know, the only way you're going to do this is have some resources there for you, a person that can tutor, etc. Okay, so this one's rather lengthy, so I better stop it there. But those are there's a couple of rate times time equals distance problems. Okay, let's stop this recording.